In this video, we're going to explore process relationships in the Unix operating system, focusing on parent-child relationships and process groups. Let's begin our journey into the world of Unix processes. Let's understand the parent-child process relationship. Every process, with the exception of the init process, has a parent process. Parent processes create child processes using the fork function. When a child process is created, it inherits many attributes from its parent, such as open files and environment variables. The parent process can choose to wait for the child process to terminate using functions like wait. If a parent process terminates before its child, the child process becomes an orphan process and is adopted by the init process, which has a process identification or PID of 1. The init process is the ancestor of every other process in the system. The primary method for creating new processes in Unix is the fork function. The fork function creates an exact copy of the calling process, which is the parent process. After fork is called, both the parent and child processes continue to run, executing the same code. However, the return value of the fork function allows the processes to differentiate themselves. In the child process, fork returns 0. In the parent process, fork returns the child's process identification. If fork fails, it returns a negative value. The child process inherits most attributes from the parent, including file descriptors, environment variables, and the current working directory. Each process in a Unix system is uniquely identified by a process identification. This identification is assigned by the kernel at the time of process creation, and is used to reference the process in various system calls. To obtain the process identification of the current process, you can use the getPID function. In addition to its own process identification, each process also has a parent process identification, which indicates the process identification of its parent. The getParentProcessIdentification function retrieves the parent process identification of the current process. If a parent process terminates before its child, the child's parent process identification is set to 1, indicating that the init process has adopted the child. After a parent process creates a child process, it often needs to wait for the child to complete its execution. The wait and waitpid functions are used for this purpose. The wait function blocks the calling process until any of its child processes terminate, while the waitpid function allows the parent to wait for a specific child process to terminate. When a child process terminates, it returns a status code that indicates whether it exited normally or was terminated by a signal. The parent process can retrieve this status code using macros such as wifExited and wExitStatus. If a parent process does not wait for its child processes to terminate, the terminated child processes become zombie processes. Zombie processes consume minimal system resources, but remain in the process table until the parent process reaps them. A process group is a collection of related processes. Each process belongs to exactly one process group. Process groups are identified by a process group identification. Typically, the process group identification is equal to the process identification of the group leader, which is usually the first process in the group. To get the current process group identification, use the getPGRP function. To set the process group identification of a process, use the setPGID function. The setPGRP function can be used to create a new process group and set the calling process as the group leader. Here's an example of creating a new process group. First, the parent process creates a child process using the fork function. Inside the child process, setPGID is called with arguments of 0, which sets the process group identification of the child to its own process identification, effectively creating a new process group with the child as the group leader. The getPGRP function is then called to retrieve the process group identification of the child process, which is printed to the console. Process groups have several applications, including signal distribution to entire groups and job control in shells, where they are used to manage foreground and background jobs. Shell pipelines such as command 1, pipe, command 2, pipe, command 3 also form process groups, allowing signals and job control commands to be applied to the entire pipeline. Let's recap. Every process has a parent except for the init process, which is the ancestor of all processes. The fork function is used to create child processes, and wait or waitpid functions help synchronize parent and child processes. Orphan processes are adopted by the init process. Process groups are collections of related processes identified by a process group identification. They are used for job control and signal distribution. Key identifiers include the process identification, which is a unique process identifier, the parent process identifier, which identifies the parent process, and the process group identifier, which identifies the process group. These identifiers have corresponding get and set functions. Understanding process relationships is fundamental to Unix and Linux system programming, enabling you to effectively manage and control processes within the system. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.